We are working through question 5, and in question 5 we've been told we're dealing with f of x, which is equal to 2 over x minus 1 squared plus 1. Now hopefully you can immediately identify what this is. Just in the back of your head you should be thinking, hey, that's a truncus. Okay, so the very first thing we actually need to do but is simply evaluate it for when our x is equal to -1. So let's do that now. So I'm going to take my function and simply put -1 into it, which means I'm going to get 2 over -1 minus 1 squared plus 1, which means that is going to be equal to 2 over -1 minus 1 is -2, squared is 4, plus 1. This is obviously just going to be a half plus 1, which is 3 over 2. Perfect. That is how you would do the first one. Nice and easy. Let's look at the examiner's report and see how people did with this. And as you can see, the state did very well with this question. 93% of the state got the full 1 mark. You can see that. That's what we did, and this question was done well. Perfect. Let's now move on to our next one, in which we are asked to sketch the graph of f on the axis below, labeling all asymptotes with their equations. Okay, so let's just come and look at what our function is and see what we can immediately recognize. So what we're doing for this question is we're graphing this. So I'm graphing y is equal to 2 over x minus 1 squared plus 1. And you can immediately identify what our vertical asymptote is simply by looking here. We're told that our domain is all real numbers excluding 1. So that tells us that we have a vertical asymptote at x equals 1. So let's now come down and just graph what we immediately know. So that information about the vertical asymptote could also be deciphered by this. Obviously, if I was to let x equal 1, my denominator would be 0. It would therefore be undefined. The whole thing would break. So that means I can put in my first asymptote here, and let's do this as neatly as possible. Neatness is very key. If you are not neat, you will lose marks. So let's call this x is equal to 1. We can also identify what our horizontal asymptote is by looking here. So the fact that we have been translated 1 unit up tells me that I'm going to have another asymptote right here. So it's going to be at y is equal to 1. So again, be as neat as you can. I might not be that neat. I'm writing on a tablet and I have very poor hand-eye coordination, and I just find it very difficult. All right, so this is y is equal to 1. And let me actually write that somewhere else, just so it doesn't get in my way. So let's just write that down here, y is equal to 1. So there are my asymptotes. All right, I'm obviously going to need to plot some points so I can graph this as accurately as possible. Don't be one of those people who just go, oh, yep, it's going to look something like this and something like this. That wouldn't be good enough. You've just randomly drawn that. You're going to need some points so you can do this accurately and symmetrically as well. Okay, so what I would first do is find what my y-intercept is going to be. So let's begin by finding what my y-int is going to be. To do that, I'm going to to find the y-int, I'm going to let x be equal to 0. So I'm going to get y is equal to 2 over, I'm just going to be left with -1 in my denominator. I'm going to square that, which is just going to be 1 plus 1. It's going to be 2 plus 1, which is going to be 3. So that means I have my y-intercept point, which is going to be 0, 3. So I can come over here, let's do this in blue. It's going to be that right there. And you might even like to label that. So let me just do, how am I going to do this? Let me just do it. Let me just write it in here, 0, 3. Perfect. I know that it's going to be a symmetrical truncus, so obviously I'm going to have a point on my other side through there, and that's just going to be helpful when I'm sketching it. I'm going to need another point, so I'm going to need another point to do this accurately, another point. But you should, we're in a timed condition here. We don't want to waste any time and, subbing in a point and finding something, you'll be wasting time. You need to make sure you are utilizing the different parts of the question. So as you can see here in part A, what we did is we found a point. We found that when we put -1 in, we get 3 over 2 out. So we've already found another point. So we could come here and say, well, when I put -1 in, I get 3 over 2 out. I have that point. So now I could come here and say, well, when I put -1 in, I'm going to get 1.5 out. So it's going to be there, and it's symmetrical. So on this side, I'm going to have a point there as well. So you would have wasted a lot of time if you had to find a point by yourself by subbing something in. Utilize what you've previously done to save yourself time. Okay, now we come to a very important part, and that is sketching the graph. VCAA does care about how you sketch it, especially when it comes to asymptotes. So do this as neatly as you possibly can. So that is not that great, but it will do for my purposes. You should try to be as neat as you possibly can, especially when it comes to asymptotes. Don't cross the asymptote, and also don't do this. Let me show you. So if I just come down, VCAA does not like it when I screwed that up. Let's try that again. VCAA does not like it. So again, this line should be straight. When you're doing this, you should come down. They don't want you to veer away from the asymptote in any way. You should not be veering away from it. You just want to, as nicely as you can, without crossing it, just be doing that. Be very careful with it. Don't mess it up. All right. So again, you should be a lot neater. I'm drawing on a tablet and have no coordination. That is my excuse. But if I had a pen and paper, it would be far neater. Let's now look at the examiner's report and see how people did with this question. So as you can see, 69% of the state got the full 2 marks. Our graph looks good. We have both our horizontal and vertical asymptotes. They're both labeled. Very nice. Let's come and see how people messed this up. It said most students correctly recognized that a truncus shape was required, and most of these students located it correctly. Again, curvature was an issue for some, with graphs turning away from the asymptotes or crossing them. Students who made use of their answer to part A and found the y-intercept were most successful in producing a correct graph. Those who did not recognize the truncus tended to draw a rectangular hyperbola with correct asymptotes. So I think a very important statement right there is that those students who were most successful were those who utilized their answer from part A and who also found the y-intercept, and that enabled them to produce a very accurate graph. And also be careful of the curvature. It is important. Okay, let's now tackle the very last part of this question, and that is part B. Let's read it. What does it say? It says, find the area bounded by the graph of f, the x-axis, the line x equals -1, and the line x equals 0. So we're finding area, so we know that this is going to be an integration question. It's the function, the x-axis, and these 2 lines. So if we come up and just kind of visualize what we're doing here, we know that we are bounded by the x-axis, we are bounded by the curve, and the lines x equals -1. Let's see if I can draw that a bit better. So this one right here, and also here. Okay, let's see if I can draw that straighter. So we're finding this area right there. That's what we're finding. Okay, so that's just really to help visualize what we're doing, but let's now actually do the maths. So I'm going to put my integral sign. What is my formula? It's 2x minus 1 squared plus 1 dx. What are my upper and lower limits? It's going to be 0 is my bigger number, -1 is my smaller number. Okay. So once we've got it into this form, there are obviously various ways you could go about integrating it. I'm just going to show you the way I prefer to do it. I would begin by taking 2 out the front, and I'm going to be left with 0, -1. This is obviously going to be x minus 1, -2. So I've simply changed my exponent there, and I'm also going to deal with both of these parts separately. So I'm going to integrate them separately. So that means I'm going to have that 0, -1, 1 dx. Now, the reason why I'm doing that is because I know when I'm dealing with a integral of a constant, it's simply going to be whatever this is, so in this case 1, and then I'm going to multiply that by the difference in my boundary. So 0 minus -1 is +1, so it's simply going to be 1 times 1. Perfect. I then come back to this and deal with this. So now I'm going to be integrating that. So I put in my square brackets here. The way in which I approach this is I leave what's inside my brackets the same. I plus 1 to the power, and now I divide that by the product of the coefficient of my x, which is 1, and my new power, which is -1. So that is what that is going to be. I make sure that I put in what my boundaries are, 0, -1, and then I put my plus there. So let's keep on going now. I'm now going to simply rewrite this. I much prefer to think about this in terms of being -1 over x minus 1. That's a far better way to think about it. 0, -1, and remember I have to plus a 1 to that. Okay, so now we're subbing in these boundaries, so I'm going to end up with -1 over -1 minus -1 over -2. Putting in an extra step is never a bad thing because it just means you're less likely to make a mistake. Here I'm going to get 1 minus a half because the negatives there are going to make it positive, negative there's are going to make it positive, like that, which means what I'm going to end up with is 2 minus 1 plus 1, which is obviously going to be 1 plus 1, which is 2. Now you can say 2 and just leave it there, or you could say that this is square units. Whatever you like, but you can just say it as 2. But because it is area, you could say square units as well. And there is my answer. I'm just going to highlight the 2 there. Let's now look at the examiner's report and just see how people went with this question. So if I come up here and find it, there it is. Okay, let's have a look here of how people went. So as you can see, 32% of the state got full marks for this question, the average mark being 1.1. As you can see there, they just left their answers merely 2. They didn't put square units in, and that's perfectly fine. You can just put 2 in. Students were generally able to set up the correct definite integral, but often did not find the correct antiderivative or evaluated it incorrectly. The most common errors were an antiderivative that involved a log component or overlooking the +1 constant when anti-differentiating. So the +1 constant is referring to this little thing out there. So overall, not a bad question at all. This is question 5. Hopefully you found this video helpful if you got stuck anywhere there. But overall, very nice question and nothing too tricky. I'll see you in the next video.